this lesson, we're going to be talking about how to graph a function or a function rule. You're going to need your graphing calculator, so make sure that's handy. So let's first take a look at this, this first slide here. You'll notice that I have this equation up at the top. This is called my function rule. We're going to be talking a lot about what is a function, but today's lesson, what I'm going to show you is how to graph it, how to put it on a coordinate plane. So you'll notice down to the left, I have a nice picture of this, this function rule. This is what it looks like graphed. Now, the way that you graph it in your calculator, you press the button y equals, and a screen will pop up that says plot 1, plot 2, plot 3, and then y1, 2, 3, all the way down to 7. Right next to the equal sign where it says y1, I want you to type in x minus 3. Great. Once you type in x minus 3, go ahead and press the graph button. The graph button is found right under the actual screen. It's one of the 5 gray buttons right under the screen, and it's on the far right. So once you press graph, you can see that you have the graph that I have here. So anytime in class that I ask you to graph a function or graph an equation, you're going to go to the y equals button, pop it in there, and press graph. Okay, the other skill that you're going to need for today's lesson is how to create a table of values. So over here on the right hand side, I give you the directions on how to do that. So again, you would go to your y equals and you would put in your equation. Right now we already have the equation x minus 3 in there, so we'll just play off of that one. The second direction is you want to press the second button. That's the blue button. So press second and then press the graph button. And what that will do is it'll create a table of values. What that is saying is if we look at the table of values that I give you down here, so if I take that first number, you'll notice that it's highlighted and it's 0. It might look a little bit different in your table. It's just I scrolled to 0 whenever I took this screenshot. So what it's saying is when the value of x is 0, the y value is going to be negative 3. So if you look at our function up above, I have, I'm actually going to write it down here. I have y equals x minus 3. So what it's saying is this. I'm going to substitute a 0 in for x. So y equals 0 minus 3. When I do that, you can see that my y value is going to equal to negative 3. What this table of values does is it creates all of the x values that correspond with the proper y values according to this function rule. So if you, on your calculator, if you use your up and down arrows and scroll up and down, you can see that the numbers are endless. They'll go in the negative direction forever and they'll go in the positive direction forever. So we're really only going to be looking at a couple of these numbers today. So you won't need all of the numbers. Okay, let's go ahead and graph our first function rule. All right, the directions say construct the graph of a linear function. So this year, Algebra 1 is broken down into different functions. Some are linear and some are not linear. And we're going to be focusing most of the year on linear. So let me show you what a linear equation looks like. Okay, so this is my function rule that they give me. Y is equal to negative 2x plus 4. We are going to learn all about this type of equation in Unit 4. But right now, we're just building up to that, and we're learning how to graph it. So what I'd like you to do is I'd like you to go back to your y equals, and I would like you to clear out your y1. You can press the clear button, or you can press second plus 712, and that will clear out everything. Okay, I'm going to put in negative 2x plus 4 right into my y sub 1. And I want to then create my table of values. So I'm going to press second graph. All right, take a look at the x and y values that I am given. You'll notice that if you go to x equals negative 2, that will correspond to a y value of 8. If I were to put this on my coordinate plane that I'm given right now, it actually wouldn't fit. So I'm going to choose values that are going to fit on my coordinate plane. The first one I'm going to choose is going to be negative 1, 6. So I'm going to write down negative 1, Okay, and what I'm going to do is I'm going to take all of those numbers right beneath -1 and 6, and I'm going to put them in my table of values. So I'm going to put a 0, 4, and then I'm going to put a 1, 2, and then I'm going to put a 2, 0, and I'm going to put a 3, -2, and I'm going to go ahead and put a 4 and a -4. Now, right now, that's all that fits into my table of values. I could use more, and I'll show you that in a moment. So now what I'm going to do is I'm going to take my coordinates, my x and y coordinates, and I'm going to put them on my coordinate plane. So my first coordinate, you'll see here, I have an x and a y value. So this is actually how I write a coordinate. -1, 6. So I'm going to go ahead and graph that. I'm going to start at my origin. I'm going to go to the left 1, and I'm going to go up 6. And I'm going to put a nice dot right there, a nice big dot. All right, 0, 4. I'm going to start at my origin, and I'm not moving left or right at all, but I'm going to go up 4. 1, 2. I'm going to start at my origin and go to the right 1 and up 2. And I'm going to go ahead and continue this process. Okay. Now, you will notice here that you're probably seeing a pattern with the dots, and you probably want to put another dot right here. Well, you're absolutely right. On our table of values, if you went down one more, you would have 5, -6, and you could put that on your coordinate plane. So now that we've got all of our points plotted, because this is a linear function, meaning it has a y equals something x plus something, this is actually going to construct a line. So going through all of the points, you want to draw a nice straight line. Now, the line is actually going to have arrows at the end, meaning that this line is going to continue on and on and on in both directions forever. Now, you want to make sure when you're graphing your lines, you use a nice straight edge so that your lines are very nice. You can see mine's a little bit wobbly because I don't have a straight edge on my device. And the other thing is you'll notice that my arrows extend off of my graph. I would like yours to do that as well. Okay, let's try to graph another linear function. This is kind of an interesting one because it looks a little bit different than the first one. It doesn't have that constant value. So let's see what that does to our graph. Let's go ahead and into our y equals, let's go ahead and clear that out and let's put 1/2. I'm actually going to write it as 1 divided by 2 and I'm going to put an x. Now, just as a reminder, I didn't mention this on the last one, but your x value, that variable x, you have to use the button that, that looks like this. Let's see if I can draw it. X and then a T. It looks like this. This is the button. It's right below the mode button, and it's right next to, to the right of the alpha button, the green button. That is your variable button. So you cannot do the alpha button and then choose your X. It has to be this, this button. Okay, now that we've got that right, let's go ahead and press second graph. That's going to construct our table of values. And I want you to take a look at some of these values. So you'll see in there that some of them are actually decimals. You can use those points. They're perfectly fine. But if I have another option, I would definitely use those options. For example, I have, let's see, -6, or let's start with -4. That looks like a nice one. No, -6, -3. Let's do that. -6 and -3. Coming after that, I have -4 and -2. And then I have -2, -1. I'm going to scroll down a little bit more. I have our origin, which is 0. I have 2 and 1. And then I'm going to do one more, 4, 2. And again, you can absolutely go ahead and put more values in your table. But this is all I had room for, so that's all I'm going to do. Now I'm going to go ahead and pop it on my coordinate plane. Start at my origin. So I'm going to go -6, and I'm going to go -3. I'm going to go -4 and -2. -2, -1, 0, 0. You'll probably start seeing a pattern at this point. 2, 1, and 4, 2. And you can see that we're also missing another point here. If you'd like to go ahead and put 6, 3 on here, go for it. Okay, now that it's extended all the way across your coordinate plane, let's go ahead and connect the dots. And one more thing before I do that, a great way to catch yourself is if you accidentally put like a dot way out here, well, you're not going to have a linear function that has all these dots in a row and then some random dot over on the side. So just be careful with that. That kind of tells you that you made a mistake. All right, I'm going to go ahead and I'm going to draw my nice clean line right across my coordinate plane, and I'm going to draw my arrows extending off of my graph. And you have just graphed the linear function 1/2 x. Now, if we look at this one and we look at the previous one, we can see that this particular linear function goes through the origin, whereas the other one did not. So we're going to talk about this a lot in unit unit 4, but you can see that this one is intersecting at 4. That might have something to do with this constant number in our equation. And then if we go back to the one we just did, you can see that we don't have a constant. So really it's like plus 0. And you can see that the graph is going through our origin. So those are the kind of the connections that those graphs are making with the coordinate plane. Okay, let's try another one now. All right, now we're going to look at something that is non-linear, meaning it's not a line, it's something else. So let's go ahead and look at our function rule. This function rule is a little bit different now. We have y equals x squared minus 2x. This is called a quadratic function. We will be spending an entire unit talking about quadratic functions, and I will review this process of graphing one later on. But I wanted to show it to you now, just so you kind of got an idea of how to graph all functions. So let's go to your y equals and clear that out, and go ahead and put your x squared minus 2x into your y sub 1 and make a table of values second graph. You're going to need to kind of scroll up and down and see which values are appropriate to put on this coordinate plane. And it looks like if you look at -2 as your x value, well, 8 is way too big. So I'm going to bump down to -1. And I'm going to write -1, 3. That's going to be my first coordinate. Then I'm going to keep going. It looks like I have my origin. And it looks like I have 1, -1, 2, 0. I'm just going to keep on scrolling down here. Looks like I have 3, 3. And I'll put one more on there. Actually, this one's not even going to fit. You can see 4, 8. Even if I put it there, it's not going to fit on my coordinate plane. So let's go ahead and graph these, see what they look like. -1, 3, 0, 0, 1, -1, 2, 0, 3, 3. And 4, 8, you can see that that's actually going to take me off of my coordinate plane, so I am not going to graph that one. So we'll just put a little line through that one. Now you'll see that my line is no longer a line. This is actually going to be a curve, or something we like to call a parabola. So let me show you how to graph this one. I'm going to start off of my coordinate plane, and I'm actually going to draw a real nice curve with a curve at the bottom, extending off of my graph with arrows. Again, this is called a quadratic equation, and it's also a parabola. We're going to spend a lot of time on this a little later on in the year, but I wanted to show you how to graph it. And I'm going to show you another unique one. We've worked a little bit this year already with absolute value equations, so now we're actually going to graph one, see what it looks like. So if I go to my y equals and clear that out, if you remember from unit 1, we actually used an absolute value symbol, and you might remember where you found it, and I'll remind you, it's going to be under the math button. You're going to go over to num, N-U-M, and it's going to be choice number 1, abs. So you're going to select that, and you're going to type within the absolute value, x plus 3. And you'll see there's going to be a little arrow in your calculator. If you just click over to the right, it'll take you outside of the absolute value symbols. And if you want to see it on your calculator, I didn't mention this before, you can actually press the graph button right now, and it'll show you what it's going to look like. But let's go ahead and create our graph on our own using our table of values. So I'm going to press second graph, and I'm going to look at all my values there. Now there's lots and lots and lots to choose from. So I am going to start with, I think I'm going to start with let's look. How about -6, 3? I like that one. So -6, 3. -5, 2. Keep going here. -4, 1. -3, 0, -2, 1, -1, 2, and let's see what we can use with those ones. Let's go ahead and graph them. Remember to make nice, nice big dots. Not huge, but you know, a nice portion size. -5, 2, -4, 1, -3, 0, -2, 1. Oh, this is interesting. -1, 2. Let me go ahead and erase that little piece that I made there. There we go. Oh, bouncing me everywhere. There we go. And if you want to, if it's bothering you that we need to put one more right here, go for it. That's fine. That's 0.03. You'll see that I actually have 2 lines, and this is an absolute value equation. This is what they all look like in some form or another. And I'm going to go ahead and I'm going to connect my V. And there is my absolute value equation. And the reason that it looks like a V is, if you think about absolute value, and we talked about this in Unit 2, where you have this value of X, and there are 2 different possibilities that you could have for X, and you know, at every single point on this coordinate plane. So it actually accounts for the negative numbers and the positive numbers, and that's why it has 2 lines connected to it. Okay, let's see what else we have here. This time, what we're going to do is we're going to determine the function given a table of values. So now we're kind of working backwards. We're given a table of values and we're trying to figure out, well, which function does it connect to? So here's where I always like to begin with these. I like to look where my X value is 0. And in our first table here, we actually have an X value of 0. With an X value of 0, it will make your Y value 8. Now, I like starting with 0 for the same reason as I use 0 for our check step in the equations unit in Unit 2, where it kind of, 0 is really nice because of the multiplicative property of 0, it cancels something out. So if you think about it, if I substitute 0 in for X into these equations, I want to know when will Y be 8. So if I look at this first equation, and if I put a 0 in for my X, well, that's going to give me 0 plus 6. Meaning Y would be 6. Well, that's not right. If I look at this equation Y equals X squared plus 1, if I do the same thing, if I put a 0 in for my X squared, it's going to be 0 plus 1. And Y is going to equal 1. Well, that's not it either. Over to the right, if I put a 0 in for -6 times 0 minus 3, that's going to give me a Y value of -3. Well, that's not it either. And of course it is going to be this top one, because if I put a 0 in here, it's going to be 0 plus 8, which is going to give me 8. And you do want to check each one of the other points, but since we already checked these other 3 equations, and if it doesn't work for one point, it's not going to work for any of them. So in this case, our answer is going to be Y equals -2x plus 8. Okay, and this next one, it's a little bit different, because if you look at our table of values, we don't have an X equals 0. So personally, what I like to do is I like to pick the easiest number, and I like to substitute it into the equation. So pick any number that feels reasonable for you as an X value. I'm going to go with, I don't know, 4. Let's work with 4. So when I substitute an X value as 4 in, I want my Y value to equal 5. So let's look at the first equation. Y equals -4. Well, -4 times, if I substituted a 4 in there, my Y is going to give me -16. Which is not correct. Okay, let's look at the next one. Y equals X squared minus 3. All right, well, if I put a 4 in there, it's not going to be 4 squared, which is 16. And if I subtract 3 from that, it's going to give me Y equals 13. Well, that's not right either. All right, Y equals 2x minus 3. Well, if I put a 4 in there, 2 times 4 is going to be 8. And if I subtract 3, well, that's going to be 5. Ooh, interesting. All right. Now we have something to work with here. So since I have something on this equation, let's go ahead and choose another value. Let's choose the one right below it, 6. So let's say 2 times 6. 2 times 6, well, that's going to give me 12 minus 3. Uh-oh, that's going to give me 9. This value right here is not 9. And therefore, since one point does not work, you can't make any of it work. Every point has to work. Okay, I'm actually going to go ahead and erase some of my work here, my circles, so I don't confuse you. And let's look at this last equation. 1/2 x plus 3. All right, well, let's focus on that 4 again. All right, let's take 4. 1/2 of 4, well, that's 2, plus 3 is going to give me 5. So y is equal to 5. Oh, all right, that works. Now, let's check another value. Let's check -2 and 2. So 1/2 of -2, that's going to give me -1. And if I add 3 to that, that's also going to give me 2. So that point works as well. -4, well, 1/2 of -4, that's going to be -2, plus 3 is going to give me 1, so that value works as well. You can see where we're going with this. Let's do the 6 and 6. 1/2 of 6 is 3, plus 3 is 6, that works. And the last one, 1/2 of 10, well, that's 5, plus 3 is going to give me 8. So all of my values work. So you can see that my last function is the function that goes along with this table of values. Okay, so that is it in this unit, or in this section on graphing functions and linear functions and nonlinear functions. So feel free to pause the video and repeat it as you go.